right, folks. We are finished in the asteroid belt. And one of the big things we noticed about the asteroid belt is how few asteroids there are out here. If you look within a space of about 1 or 1,000 even square miles, you're maybe going to see one. And that's why we don't have to worry about our spacecraft hitting them as they go to explore these deeper planets. So without further ado, let us, without worry of an asteroid hit, pass right through the asteroid belt to our next location. So here we are on good old Jupiter, the stormy planet. So as far as its history goes from its name, anybody know what the Greek equivalent of Jupiter is? The king of all Roman gods. Therefore, in Greek, Zeus, yes. From this slide, just go ahead and write down the second bullet point. Kind of makes me uncomfortable that as we seem to go further out into space, they are wearing less and less clothing.
Wait, did you want the whole slide?
No, just the second bullet point.
In that case, can you skip to Pluto?
No.
That point's going to be a skeleton.
I'm not even wearing any skin. Oh, that didn't take long. So yeah, a little bit of history there. I don't really know what the bird is. Anybody know what the bird's about? I don't know. All right, so as we descend and we get closer and closer to the surface of Jupiter, it begins to look a little bit like this. In the distance, we see several of Jupiter's moons, which we're going to land on later. But as we go further and further down, you see that we have some clouds here. They are not white like on Earth. They are kind of a reddish-brownish color. We'll see why that is later. You're also going to notice some of these storms. And as we get closer and closer to them, you realize that they are much stronger than the storms we have here on Earth. For this slide, go ahead and write down, you can write down the whole thing. It'll give me some time to pass out the handouts. So unlike the planets that we visited so far, Jupiter is known as a gas planet, a gas giant. And so what that means is there's actually no surface that we could reach and walk around on. All that's going to happen is as you descend through the clouds, those clouds would seem to get thicker and thicker and thicker, like falling through fog that might get thicker and thicker. And eventually you get to a point where that fog is almost just all water. And that's kind of what happens as we descend through Jupiter's clouds here. The pressure increases, and so we have more and more water as we go deeper and deeper. So I try and compare certain things about even the gas planets to Earth, and so we have to have some sort of defined surface. And the way I define that is the pressure. So on Jupiter, where the pressure is equal to 1 bar, that's where I define the surface of Jupiter, because that's the pressure that Earth has at the surface. So you can see we've dropped several probes into Jupiter. Of course, they don't last real long. Any guesses on how far the deepest probe has survived into Jupiter? Below the cloud tops, how far do you think they've gone before we've lost transmission? 5 miles, perhaps? 10 feet?
What was the question?
How far have the probes that we've sent into Jupiter survived below the cloud tops? They survived, the deepest one survived about 100 miles down. And eventually I'll have you write that down. That's in one of these slides. But one of the cool things is as we descend through Jupiter, it's not just one cloud layer. You've got several, and sometimes you'll even see spaces between those cloud layers. And this is one of those spaces. This is a real, I mean, it's not like, this is not what the color would look like, but this is the structure of those clouds taken from like sonar technology. Yep. Go ahead and write down the first bullet point and the third bullet point. Yep, first and third. Yeah, this is close enough. Just have to fill it out the rest of the way for me. October 1st, 1245. Anybody know what this is called here?
The red eye.
The what?
The red eye.
The red eye? You're close. You're very close. We're going to talk about that little spot in a little while here. It does look like a little pimple, doesn't it? Yes, it is. It is a hurricane. The real question would be how big is it? Because Jupiter's a lot bigger than the Earth. And we'll see the size comparison in a little while. So this is a picture of what Jupiter looks like from close up. And you can see that we've got almost, it looks like watercolors here with brown and red and orangish colors and white there, different bands. And this next slide is on your handout. What I'd like you to make note of on your handout are the bottom 3 bullet points here. So again, just take note of these 3 bullet points here. The powerful storms are made because of strong convection currents, and I'll point that out further in the next slide. But the reason it's so colorful is because these storms, and convection is, bringing things up, and then it cools, and then it goes down. And then as it warms up, of course, warm air rises, and it brings all that stuff from underneath, and it just continues to go like that. And because these currents are so strong, you've got all sorts of material from deep inside Jupiter that's being raised up to the cloud tops. And that's why we have all this dark material up there. It comes from much deeper inside. And you can see this is just convection. You've got the warm stuff coming up, making up the clouds. It cools, and then it descends, and you have that cycle. This is also on your handout. In terms of this slide, you don't have to point anything out, but one of the ways to figure out exactly why it is that Jupiter has such enormous storms that are way more powerful than anything we'd see here is when you have those strong convection currents and they continue to act like that, it has an effect on the jet streams above where the convection is occurring. So if you kind of think of it, if you've got one column of air moving this way, another column of air moving that way, that's how tornadoes form, when you've got those two different air masses moving in different directions. You can just see that by putting a pencil or a pen in between your hand, and it goes back and forth. When you've got that rotating column of air, you've essentially got a tipped-over tornado, and it's only a matter of time before those start to go the right side up. And this is another picture of the sort of thing you'll see between these cloud layers because of all those storms and all those strong convection currents that are going on in between the clouds of Jupiter.
That's cool.
Yeah, that's a neat one. And this is also on your handout. So once again, you're going to sink down into Jupiter's surface. Once we reach the place where the pressure is the same as Earth and we get out, we're not going to be able to walk on anything. We're just going to sink down through what appear to be clouds. Yeah, they'll be like brownish probably, depending on where you land. But those clouds and the surface atmosphere is mostly made up of hydrogen, a little bit of helium. Those are the two most common elements in the whole universe. Storms are everywhere, way much stronger than the storms here on Earth. This is an actual picture taken of Jupiter. Any guesses on what all these bright flashes are? Yeah, that's lightning. And you can see them from a long, long ways away in space. And you'll see in a little while exactly how big some of these storms can get. But the winds themselves are 400 miles an hour. That's pretty strong for a consistent wind right there. Just to give you an idea of scale, the speed of sound is 760 something. So you're going more than half the speed of sound when you've got wind that fast. Lightning 10 times as powerful as Earth. From this slide, put a little arrow next to that 400 miles an hour. Oh, sure. You can take this one if you want. It's going to be cleaner than that one. You can write this down. The atmosphere is thick, very thick atmosphere on Jupiter. So Jupiter's atmosphere, in that respect anyway, is a lot like Venus. Both have very thick atmospheres, unlike Mercury and unlike Mars. Now again, when we look at Jupiter, whether you're looking at it from close up, from a satellite picture, or whether you're just looking at it through the telescope I have in the back of the room, you're going to see this big red spot, if you have the right filters on anyway. It's also a half and half chance because it might be on the other side of the planet. But if we zoom in on this spot, you can see what it looks like with some high definition pictures there. And we call this the Great Red Spot. And it's an enormous hurricane, twice the size of the Earth. And you've got wind speeds up to 400 miles an hour. And it does not go away. From this slide, go ahead and write down that the first bullet point and write down the last bullet point. Yeah. First and last. Oh yeah. It's like a hurricane on Earth. It's going to move around. The only difference is it doesn't go away. It does actually get stronger and weaker periodically, but it does not ever go away. When I was a kid, it was 3 times the size of the Earth. Now it's 2 times, and it's been getting a little bit bigger. So it goes through cycles, kind of like we go through different weather cycles here. So yeah, it does travel around Jupiter every 6 days or so. That's a long ways, because Jupiter is way, way bigger than the Earth. 11 times the size of the Earth, to be exact. You can skip this slide, but just know that Jupiter is just enormous. And there's the little marble Earth right there. Ooh, what are some guesses? How many Earths? And again, when we say this, we're not saying how many little Earths could you drop in. It's like if you took all this mass and you ground it up and put it inside, how much do you think would fit in there? Any guesses? 32, 100, 600, 1,300. 1,300 is correct. 1,320 Earths would fit inside Jupiter. Sean said that. He is the Jupiter Master from here on out. No.
I didn't even go say how you got that answer.
Now this is kind of interesting. All the other planets that we visited have an average density much higher than this. Jupiter, though, 1.33 is its average density. The average density of water is 1. So if you took all of Jupiter and you averaged it, it's only slightly more dense than water. It is the 5th planet from the Sun, 5.2 astronomical units away, so about 5 Earth to Sun distances away. Yeah, and you can see the difference in scale here. Here's the Sun, there's Jupiter, and there's little Earth. So yeah, the scale of some of these planets is just enormous. But when you compare them to stars, you kind of put things in perspective. And if you think this is big, just wait till we start talking about stars and we see some of the biggest ones that are out there. You can write this down. Basically. Our sun is very special, though. God made it in such a way that it's not very violent, like a lot of stars that we find. It's a very well-behaved, stable star, and that would be necessary for us to actually be able to live here. So, yeah, we would expect a number like this for how long it takes Jupiter to go around the Sun once, because it's a lot further away from the Earth. So that means 2 things. Number 1, the further away you get from the Sun, the slower you're going to be moving in your orbit. So that's one reason it has such a long year. The other reason is it's traveling in a much bigger circle. You know, the further out you are, the bigger that circumference is going to be. So, in addition to that, it spins on its axis in only 10 hours. Jupiter is booking it. That is a short day. You'd have to have a school day that's like 3 hours long. Of course, then you'd only be able to sleep for a little while. But what this means is when you combine that fact with the idea that Jupiter is very, very... I've always tried to look for a word that means the opposite of dense. The only one I could come up with is sparse. So if anybody can come up with a good word that means the opposite of really dense, let me know. But Jupiter is so not dense that when it spins this fast, it bulges out at the sides quite a bit. So it's not a perfect circle by any means. It's bulging out at its equator. Temperature at 0.1 bar. So this would be the temperature at the cloud tops on Jupiter. You can write this down. It is a cold, cold area. Yeah, we're going to take our next temperature measurement at 1 bar, where the surface pressure would be the same as Earth.
Wait, so
Is that
if
just like
it's,
the all?
if it's all gas, is it still like really hot?
Once you get deep, far enough in there, yeah, because the more pressure you have, the higher your temperature is going to be. So temperature is more or less determined by pressure on these outer planets, as opposed to the sun directly beating on you. So yeah, this is how cold it is at the tops of the clouds. How cold or hot do you think it is when we get to the spot where it's the same pressure as Earth? 600 degrees perhaps? 40? 25. The temperature at 1 bar, or the surface pressure on Earth, is a balmy -162.
So why is there a plane?
So you can go ahead and write that one down too. And the further you would descend, the more pressure you'd be under, and the warmer you're going to get.
Would you die? We would die from the pressure.
Oh, we're going to talk about exactly how we die at the end. I don't want to spoil it yet. We should bring we'll say that we're bringing a sacrificial freshman with us for every planet that we kick out onto these planets. So we'll see what happens. Okay. Sure. So Jupiter also has a pretty strong magnetic field, just like the Earth. Jupiter's is much stronger, though. It is the largest and most powerful magnetic field in the solar system. It's made about the same way as Earth's and maintained about the same way from our core. What I'd like you to write down from this slide is the fact that it can be felt beyond the orbit of Saturn. So write down can be felt beyond the orbit of Saturn. I suppose that still kind of works. I mean, how else would you pronounce it, right? Beyond. How do you get rid of the Y sound? Beyond. Now, the reason that the magnetic field can be felt so far back is because, again, the sun, even at this distance, is smashing Jupiter with its solar wind, with all that radiation. And that radiation interacts with Jupiter's magnetic field. It pushes it back, and it pushes it back so far that even Saturn can feel it. Also, because Jupiter has such a strong magnetic field, it's going to direct a lot of that solar wind to the poles. And you're going to experience the northern lights on Jupiter way better than you would here on Earth. So that'd be one cool thing about going to Jupiter. You're going to see some pretty cool solar wind northern lights there. Yeah. For this slide, go ahead and write down auroras and just the first bullet point. You don't have to write anything underneath. And just to give you a little taste about how bright and how magnificent these things would look, you know, it's one thing to look at the northern lights from a long ways away, and you know they're bright and they're spectacular, and you can see the sort of thing that you would see. But when you're that far away, you just can't get a good appreciation for how it would look close up. So if the northern lights on Jupiter look this cool from that far away, just imagine what it would be like to be like right here or right here. That would be quite the light show.
Seems blinding.
Yeah, but dang, that's a good way to lose your vision. If you're going to go blind, that's a way to do it. As far as water and ice go, there is a tiny amount in the vapor in the clouds. Not so much that we could like stick a cup outside of our spacecraft and get something to drink, but there is a small amount of water vapor in those clouds. This here was the very first picture that was taken close up of Jupiter, and that came in 1979, courtesy of the Voyager 1 spacecraft. It was the first spacecraft that got a good close look on the planets that we hadn't seen up close. So that's the very first picture, historic picture there. And after the Voyager 1 took this picture and it flew off, beyond Jupiter, it looked back and it was able to grab a picture that looked like this. Anything stand out to you on this picture? So this is the outline of Jupiter here. You can kind of see some of the atmosphere. And then, yeah. Any guesses on what this is? Nope. This is a ring. There's actually a tiny little ring that goes around Jupiter. And the only way you can see it is if you're behind Jupiter, so the sun isn't, in your eyes, and the sun's reflecting off perfectly the ring itself. So we're not going to see this like through a telescope or something, but if you're at just the right angle, you can see that Jupiter has a ring. This is a more updated picture from 2017 from the spacecraft Juno. You get a little bit better definition from some of these clouds right there, and you can see lightning. In terms of its composition, I don't have to have you write this down. All that's happening is as you descend through the clouds, those clouds get thicker and thicker and thicker, and eventually you get to a point where it's like, I'm not falling through clouds anymore, I'm just in liquid. And that's the transition that you would make, going from gas to liquid. It would be a smooth transition. But yeah, eventually there's enough pressure where you've got a metallic hydrogen and then a core that is actually solid. No, you can't fall straight through. In terms of gravity, right down 2.5 times Earth's gravity. That cat either ate a watermelon or it's on Jupiter.
What do we write on this one?
Just 2.5 times Earth's gravity.
No way.
So if you're looking for a workout, Jupiter would be a good place to get it. It'd be kind of interesting to just live on a place that has that much gravity. It's like, how strong could you get by existing there and getting used to that? Of course, it would destroy your spine and everything, but whatever. 2.5 times Earth's gravity. So you're not going to be able to jump very high. In terms of the sun, if the sun looks this big on the Earth, it will look this big from Jupiter. So now it's getting pretty small. When can we see Jupiter from Earth? Just at nighttime. It's not bright enough to be seen during the day. From this slide, go ahead and write down that it's the 4th brightest thing in the sky behind the Sun, Moon, and Venus. What's it? Oh, yeah. We see it quite a bit whenever we go out for astronomy club to make observations. We're actually going to be doing one of those October 23rd, whatever the Friday of Student Help Day is. So if you guys are interested in that, feel free to join us. If you want more information on the Astronomy Club, just leave your name and I can add you to the Schoology group if you can't make those meetings. But yeah, Jupiter looks like a bright star when you're looking at it from Earth. This is Jupiter right here, so it's much brighter than the surrounding stars. But it doesn't look, as big as the moon or anything like that. This is the sort of thing you'll see when you look at Jupiter through the telescope in the back of the room there. Whitish brown disk with some bands if you have the proper filters on. And you can also see the great red spot if you're looking at it and it's actually on the right side. I don't see it right here, but you can also see that too. Jupiter's moons will eventually start talking about those too. What's the sky look like? This is a pretty good representation of what it would look like on Jupiter. This looks kind of like water. This would be another cloud layer, actually. During the day, it's actually blue. Unless you go far enough down, then it would be darker and darker, turning red and brown as you descend. At night, it's obviously black without the sunlight.
Are those actual pictures?
No, this is not an actual picture. Now, one of the pieces of news that happened when I was a kid was in the mid-90s. Jupiter got hit by a comet. It broke up, the Shoemaker-Levy comet, and that comet collided with Jupiter in 1994. This is a thermal image of that collision, and so you can see there was just a massive spike in heat as it ran into Jupiter's atmosphere. Now, Jupiter doesn't have a solid surface, so it's not going to make craters, but as it does go down, it still causes enormous explosions, which brought up all sorts of material from deep inside Jupiter to the surface. Almost kind of looked like Jupiter had a black eye or something. And when you compare with how big this scar is on Jupiter to the Earth, it gives you an idea of how big that impact was. Yeah. Imagine having a crater the size of our planet. So, what happens if you, when we sacrifice our freshman and kick him outside our spacecraft on Jupiter? Any guesses on how he's going to die? Yeah, so on Jupiter, it's going to be a very quick death. What's going to happen is you're going to be crushed, burned alive, wind blasted, and drowned all at once. Because all these things would come together to end your life at pretty much the same moment. Professional wrestler in the 90s. If you have a spacesuit, you'd avoid a lot of this, but you'd still be crushed very, very quickly. Or, Jupiter has that really strong lightning. You could fall victim to that. I thought it was funny. Anyway, you can write this slide down. You don't need to know the specific gases. If you want to skip those, you can. That's fine. Fitting that we have Krypton up here on Superhero Day. That's gotta suck for Superman, doesn't it? It's like you can make Krypton, so he's basically useless if he comes near you. What's that? Yeah, add that too. I suppose it could be worse. I mean, what if your weakness was water? Yeah, reverse Aquaman. So, these gases, when you think about them in terms of the nebular hypothesis, which is the idea that gases came together and formed these planets on their own, these gases are not stable this far away from the sun. And so the question would be, how did they become stable if Jupiter somehow formed in that way? And they can't. There's no explanation for that. The other cool thing about Jupiter is it's actually our protector. That Shoemaker-Levy comet was heading towards the inner solar system. So it's like, who knows what kind of damage that could have done if Jupiter hadn't intervened and taken the hit for us. And, who knows how many times this has happened in the past.
Did it really do much to Jupiter?
Well, in the end, the clouds went back to normal. But, you saw those scars. They were Earth-sized. So Jupiter is bigger and heavier than all the other planets in the solar system combined. The last thing I would like you to write about Jupiter is what it comes in first place for. A lot of awards for Jupiter here, unlike Mars.
First place.
I don't think Mars got first for anything.
Yeah.
What a loser of a planet. What's that?
I got first for being last.
Yeah, first for being last.
Yeah, how many moons are there? Like 27?
Jupiter's got, I think, over 50 moons.
Oh.
It has 4 major ones that we'll look at later, but for what it's worth, Jupiter comes in second place for the most eccentric shape. So it is the second most planet that is bulging out at the equator, and second best lightning. There's even stronger storms elsewhere in the universe.